Okay, so let's talk about hypertrophy. Step number 5, and of course we are doing 12 lead EKG interpretation. So, hypertrophy. In a normal scenario, the left ventricle is the largest portion of the heart. It has the most meat to it, which makes sense. It has to generate more force than any other part of the heart in order to create blood pressure for your entire body. That's why typically our vector, our mean QRS, is down and to the left because that's where that larger portion of the heart is and that sort of stuff. However, if for whatever reason the heart is misshapen, it will cause a change in the way the electricity flows through the heart. That is to simply say, hypertrophy or increase in muscle mass or even dilation alters the mean QRS. So let's walk through some examples and we'll show you how. So atrial hypertrophy, we'll start easy. You can have either the right or the left atrium be blown up larger than they're supposed to be. The most simple way, honestly, to figure this out is what you're seeing on the screen right now. And it's that we're going to look at our 2 lead and our V1 every single time for both left and right atrial enlargement, and that will give us the exact clues we need to figure out which one is going on. So we'll start off with right atrial enlargement. We're looking at the first half of the P wave because the right side starts contracting before the left. Therefore, the first half of a P wave is the right half of the heart, the right atrium. What we're looking for is a tall peaked wave, what's known as a P-pulmonale. And then in the V1, it's the same idea. We're looking for a tall peaked P wave. We'll come back to the left atrium stuff, but we'll just move on with this for now. Right atrial enlargement, P-pulmonale. Peaked P wave is greater than 2.5 millimeters in the limb leads. So lead 1, 2, and 3. Granted, we're focusing on lead 2, but keep in mind all 3 of those can show that. Most common and best one to use is lead 2. That 2.5 doesn't sound like a lot, but most P waves are just maybe 1.5 millimeters tall, so a 2.5 is really going to stand out. If you have a biphasic P wave, meaning one that either does this or one of those numbers, you're still looking at the first half to determine if you have right atrial enlargement. So in the case of a biphasic, you're looking at the first half of the P wave, and then you're looking at V1 and V6, and that's a little bit deeper than what we're focusing on today, but it is still here so that you can say someone told you at some point in time. At the end of the day, you're curious about causes and what's going to cause right atrial enlargement, also known as RAE. Well, anything that's going to tick off the right atrium. So a lot of lung issues really can be the cause. Think about it. COPD, that's backup. Backing up to the right side of the heart. Pulmonary hypertension, backing up to the right side of the heart. AFib, that's atrial dysfunction, and so you've got lots of issues there. PE, backed up blood flow, affects the right side. Late stage left-sided heart failure can eventually work its way back and cause right-sided issues as things progress. So let's spend some time figuring out what we got going on. So Same as we've always been doing. We've got step 1 and step 2. Our rate is going to be 100 on the nose, and our rhythm, again, we're not trying to make it complicated, we're in sinus rhythm. Yes, 100 is still sinus rhythm, 101 is sinus tach. Now step 3 is going to be our axis. And I'm going to, I'll go ahead and switch it into blue for this. So we need step 1, 2, and 3. So in step 1, we're looking at a positive, so we'll go up because our QRS deflects up. AVF, and we're probably a little more negative in all honesty. So that's going to, and of course check your sheet again so you can get used to this, but up and down gives us a left axis deviation. Second step, we're going to find our most isoelectric. We're positive in 1, we're awful close in 2. 3 is definitely negative, AVR is negative, AVL is positive, and this one here is also pretty darn close. So between 2 and 3, or sorry, between 2 and AVF, I like the balance of 2 better. So I'm going to go ahead and say lead 2. Is the isoelectric. Well, I'll do our usual thing. Lead 2 travels this direction. So who runs perpendicular to him is going to be the AVL. And because we looked at the left axis deviation, we're going to see what degrees the AVL sits at, and that is going to be a negative 30. Mean QRS. So this one creates a left axis deviation which doesn't really jive with the fact that we're looking for, and let's be honest, this is going to be a right atrial enlargement example. You know what's coming. It does make it a bit challenging, the fact that it says that, and I don't have a great answer for why I'm seeing left axis deviation in right atrial enlargement. I will do my best to come up with an answer for you in the future. But the next step is number 4, which is, I'm just going to go ahead and say, do we have Wolff-Parkinson's White, any deltas? And if we look, nope, we've got pretty sharp QRSs throughout. Our PRIs look awesome. So I'm going to go ahead and say no on that. Nope. Alright, so step 5. What are we doing for step 5? I'm going to go ahead and give this one a we'll stick with red. We are going to look at the P waves in lead 2 and V1. And so the P waves here are tall. I mean, check that out. I mean, really look at this. That P wave is taller than the QRS. Even this one's a little bit tall as well. AVF has a nice tall P wave. But we're going to look at this guy, and then we're going to also look at V1, and you can see that those have sharp P waves. And see what I said about a 2.5 millimeter P wave really stands out. And of course you can dig in here and do your measurements, and they definitely meet it. But we'll say peaked and peaked. And so that is right atrial enlargement for you right there. And that's that. Next one, left atrial enlargement. What's all this about? Now I'm going to backtrack a little bit to this picture. Left atrial enlargement we're looking at the second half of the P wave now, because it makes sense. First half is the right, because that's where atrial contraction starts. Second half is the left. If the left atrium is larger, it's going to create more electricity. And so in the second lead, you're going to see a larger second half of the P wave, also known as P-mitrale. V1, sorry about that horizontal mark, is actually going to be a true biphasic, where it goes above, because this is the right, and then on the left side of the P wave, it actually is going to drag it down below and make a full-blown negative deflection. And you can see here how that second half is really over-exaggerated. And again here, how there's that little shelf and then it really bumps up. Specific rules, P-mitrale, we want a P wave that is wider than 0.12, and that's just the P wave, not the PRI. So you want a long P wave in lead 1 and 2. And to really, really make it work, you want it to be M-shaped. So scratch that out. So you want it to have that M part to it. The space between the humps is greater than 0.04 seconds, meaning that you have to have 0.04 across there. But that's part one. Second part, biphasic P wave, where the second half is wider and bigger and greater than 0.4. And V1 is great for that. And that's where you have the tiny little bit and the really wide. So it's greater than 0.04. It's wider than the first half and all that good jazz. So again, what are going to be your causes? Well, it's going to be anything that you would expect to tick off or cause any backup on the left half of the heart. What's that going to be? Well, hypertension. Left atrium has to work harder to push into the left ventricle, which has to work harder to push into the body. It's just building bulk at that point. Aortic stenosis. Again, the left side of the heart has to work harder to get the blood out. Mitral regurg. You're getting a bunch of backflow into the left atrium. That's causing it to dilate. Right heart failure. Heart failure in general. Just poor flow. AFib, again, rough on those atria. Hypertrophic cardiomyopathy. You got a big, fat, thick heart, particularly the ventricles, that just, just that hypertrophic component of it is the problem. You just wind up having more muscle that's going to cause these things to stick out. So, P-mitrale is our left atrial enlargement. So let's walk through our steps and do what we've been doing. So step 1, rate. Step 2, rhythm. On slide number 84, which again is in your handout, we're going with a rate of 90 and sinus rhythm. How are we doing for axis? Well, we are in lead 1, we're positive. AVF, we are positive. So we've got up and up, which is normal. Our most isoelectric is going to be, I'm going to put money on lead 3. Look at that guy. He's hardly got anything to him. And actually, this will be really fun to look at, period. But positive, isoelectric, negative, positive. So lead 3, isoelectric, which means this is our lead 3. So our perpendicular is here, which is 1, 2, 3. AVR. And now the question is, which side do we go on? Well, we decided we were in the normal quadrant, which is here and here. So that would put us at, let's go ahead and take a look at our deal. And we're going to say that's a positive 30. How did I get at that again? Remember, look at your dial. Lead 3 is between a negative 60 and positive 120. I'm looking for what's perpendicular to lead 3, which is going to be your AVR. AVR runs between negative 150 all the way to positive 30. We're looking in the normal quadrant, and so positive 30 is within the normal quadrant. So we will say positive 30 degrees. Step number 4. WPW, and that's a negatory. There's no indication of delta waves if you look through here. Take the time, but look. Finally, step number 5, we have hypertrophy. So where are we going to look? We're going to look in leads 2 and V1. Now we're going to look for right atrial enlargement first. So the question is RAE, and do I have the peaked waves? And the answer is definitely not. You saw what those looked like last time. They look a little bit taller maybe in lead 2, but they don't meet that 2.5 millimeter that we were looking for. So left atrial enlargement. What are we looking for here? We're looking for the M-shaped wave. So we're looking for M shape. We're looking for larger second half. And so what do we get in lead 2? We definitely have the M-shaped waves. We also have a greater than 0.12 just for the P wave itself. Definitely meets that through here as well. So we're going to say positive here for sure. Just to corroborate, we're going to look in V1. And in V1, we've got a great example of a biphasic P wave, where the second half is larger than the first and it dips down. So we're going to say that one there. So we definitely hit left atrial enlargement. So sinus rhythm with left atrial enlargement. Biatrial enlargement. What happens when you have both? Because that can happen too. So let's take a look at what one of these looks like. We've got a rate of 100. We've got a rhythm. Oh, sorry, I apologize. We have a rate of 110. We have sinus tach as our rhythm. Our axis is going to be lead 1, it's positive, AVF is negative, so we have up, down. So you look at your sheet, up and down means left axis deviation. Who's our isoelectric? Looks like it's going to be between 2 and the AVF. And we'll go ahead and stick with 2 because he's better balanced. Even though it's a little bit smaller in AVF, lead 2 kind of fits better. So we'll say lead 2, which yields us, here's lead 2, and perpendicular to that one is AVL. We decided we have a left axis deviation, so we're going to stick to this corner, and AVL has a measurement of -30, so AVL, so we're going to say -30 degrees, and left axis deviation. So that's our axis for our mean QRS. I'm going to shift things over a little bit, and we're going to do number 4 over here, and we're going to say WPW. Do we have any delta waves? And we look them through. One could maybe try to make an attempt for arguing that one, but it's really not because you don't see the sloping anywhere else. So we're going to go ahead and say no on that. Step number 5. So we're going to look in lead 2 and lead V1. And what do we got? Do we have peaked P waves in lead 2 and AV1? And I'm going to say we do have peaked in lead 2. Not so much in the others, but lead 2 definitely hits that 2.5 millimeter requirement. V1 has a biphasic, and that second half is larger and wider than the, in V1, the second half of the P wave is larger and wider than the first half. So that actually meets, so this one meets right atrial enlargement, and this one meets left atrial enlargement criteria. And it is entirely possible to have both. So we're going to go ahead and say biatrial enlargement. So sinus tac with biatrial enlargement. Other fun things to look at while we're here. Not really, but we'll kind of get into some other parts of the fun stuff next. So here is ventricular enlargement. This part actually goes really, really quickly. What we're looking at is the right and left sides, just the enlargement. We're not looking for blocks or anything, just the sheer size, the hypertrophy. For this, we're going to focus on ventricular leads, the chest leads, or pericardial. We're looking at V1 and V6. So, and V1, V6. And we'll actually do the left atrial enlargement first because that's even easier to do than the right. So, check this out. You could read what it says here about tall versus deep in terms of the R and the S wave, but seeing it practically is what's going to help most. So, left ventricular enlargement. The easiest, fastest way to do it is right here. These 3 little steps. You look at V1 or V2, deepest S wave, which will make a lot of sense because they'll have a pretty large S wave. You take whichever's larger, total number of millimeters. You're going to add that to the tallest R wave in 5 or 6. If that grand total is greater than 35 millimeters, you have left ventricular hypertrophy. You can read the rest of this stuff if you really, really want, but it's going to be awful easy to forget. So just focus on this quick way to get things rolling for yourself. So let's test it out. So 1, 2, 3. We have a rate of 110. We are in sinus tach. Where are we at with our axis? Well, we're positive here, we're positive here, so we have up and up, which if we look at our sheet is going to say it's a normal quadrant. Who's my isoelectric? My isoelectric lead is going to be my AVL, because let's be honest, that's the tiniest of them. Who is perpendicular to AVL? Just draw our little picture. This is AVL, so coming through here is going to be your 2 lead. So your 2 lead is going to be your mean QRS direction, and if you look at your sheet again, your 2 lead is positive 60. So mean QRS is positive 60, which is actually pretty normal. Kind of surprising, you know, given what's going on, but that's how we calculate it. All right, so we have that there. Now for step number 4. Is Wolf Parkinson White, and do we have any delta waves? And the answer is going to be no. These are all really nice, straight and clean throughout all of it. Step number 5, we're going to look at lead 2 and lead V1, and V1. And what are we looking for? Well, we're looking for peaked P waves. So, and I don't see anything that really resembles a peaked one. So we don't have right atrial enlargement. But do I have any kind of widened or M-shaped P waves? Not really. But if you look really close at V1, you kind of have to zoom in there a little bit. You can see that it is biphasic, and the second half is larger than the first. So, and this will happen. You may not see it in the 2 lead, or even, but you do have a pretty flat 3 lead. Either way, that biphasic in V1 is, with a wider second half, is enough to say you do have some left atrial enlargement. Not massive, but enough to get your attention. Finally, step 6. We are going to take in V1 or V2, whichever, we're going to look at the S wave and figure out who's got the longest one. And so between V1 and V2, I'm going to go ahead and say that V2 has it. How are we going to count this? I'm going to cheat for doing this to try and make it simple and save time. But we're going to count all the big boxes first. So I'm going to take this one right here. Now I'm just going to count number of big boxes. So 1, 2, 3, 4, 5. So 5, 10, 15, 20, plus about 2 more. So we're going to go ahead and call that 22 millimeters for the S wave, because we're only measuring from here down. So I'm going to say my S wave is 22 millimeters. And now we're going to go to V5 and V6, and we're going to look at the R wave and see who has the largest one. And between 5 and 6, I'm going to say 5 has the largest. And we're going to do the exact same thing. I'm going to just draw a box around him like this. And I'm going to count. There's 5. We'll just count our big boxes. We'll say 5, 10, 15, and we maybe got another 2, so 17, and we'll just say 3 more. So 17 plus 3 is going to be 20. Add those up, that's 42. That is well larger than the 35 millimeter goal that we wanted. It's much larger than that. So we have sinus tach with left atrial enlargement and left ventricular enlargement, which makes sense. The work of the left ventricle maybe is pushing back and causing the left atria to enlarge as well. But it really is just that simple. And do 20. All right. Causes, well, outflow stuff. Kind of makes sense if you think about it. Hypertension. That muscle has to work harder. Aortic stenosis. You've got that narrowing. So that's hard work. Volume or dilation problem. So that could be one of two things. You could have aortic insufficiency, which is backflow, or you could have regurg, which is basically that left ventricle, because it's leaking backwards into the left atria, that left ventricle works even harder to get what it can out through the aorta, which then just winds up creating both hypertrophy and dilation issues, because now it's trying to hold more. That regurg is also going to give you left atrial enlargement too. Another type of volume one is fluid overload. Or boluses. And that kind of is the idea, though. We may bolus people to get them all that extra fluid they need to help maintain their blood pressures. So it wouldn't be impossible to see some enlargement after some rapid high volume bolusing. All right, right ventricular hypertrophy. This one's actually not too bad to do either. What we're going to look for, well, I guess, right ventricular hypertrophy. Here's what most often it's pulmonary hypertension that causes it. Now, what can cause pulmonary hypertension is then, either you can have it as a primary illness, maybe some people just develop pulmonary hypertension. Another one is a good old-fashioned PE. That blockage of blood flow will create a backup. Pulmonary scarring, either from COPD, fibrosis, etc. What are we looking for? Well, it's going to be this here. An R to S ratio that is greater than 1. And we'll walk back to that in a second, but we'll just go ahead and make note that right ventricular hypertrophy, RVH, may cause a right axis deviation. Not guaranteed, but might. You might see some ST changes accordingly, and it wouldn't be surprising if you had right atrial enlargement too. But the R to S ratio is greater than 1. That's going to be in V1, and so we'll just show you an example real quick. So 1, 2, 3, and 4. So our rate is 58. We got sinus bradycardia. Our mean axis, and I'm going to go ahead and stick in red for this one. We are, I'd almost say isoelectric, but we can go ahead and call this one positive in lead 1. AVF is definitely positive, so up and up is, I'll go ahead and draw it up here, in the normal quadrant. Oh, sorry. I need to learn how to read my notes. I apologize. We are negative in lead 1. Which actually makes more sense now that you stare at it a little bit. So negative and negative gives us right axis deviation. Who's my isoelectric? Well, I'm leaning towards lead 1, but yeah, just it's not as small as AVR, but it really is well balanced. So let's go ahead and say ISO lead 1. And so if we do our circle, lead 1 is here, AVF is here, we're supposed to be in the right axis deviation. That's going to give us a positive 90. So degree mean QRS. And again, I apologize. I keep calling lead AVF lead 3, and that's my fault. AVF down here. So yeah, plus 90 is our score for that. Number 4 is Wolf, Parkinson, White. Any delta waves at all, things of that nature. The answer is nope. 5, we're going to look at lead 2 and V1, and we're looking for peaked P waves. And while those P waves do look a little tall in lead 2, they're not tall at all in V1. I do have biphasic there, but maybe the notchiest. I do have a little bit of notching in lead 2. Or sorry, in lead 3. So I'm going to go ahead and call between the notching in lead 2 and the biphasic in lead 1. It's not quite perfect, but it's in the right zone. We're going to go ahead and say left atrial enlargement. We are going to now look at our ventricles. So we're going to do V1, V2, and my S wave isn't terribly impressive here. And then if I look over at my R wave, V5, V6, R wave, I really don't have much at all. And I could say 5, 10, 11, 12, 13. And this one would be maybe about 10 total, which only brings me up to 23. So no left ventricular hypertrophy. So now we'll look for right ventricular hypertrophy. And what we're looking for is a ratio where the R wave is greater than the S wave. So an R to S greater than 1. So if you look closely at this, you'll see that that R wave is larger than the S wave. So if that S wave is maybe 2 or 3 boxes, the R wave is 4, almost 5. So we did meet this criteria, and so we'll say we do have right ventricular hypertrophy, which is kind of interesting. So ultimately we'll say we have sinus Brady with left atrial enlargement and right ventricular hypertrophy. And that's what we were looking for. All right, that wraps up this section. We'll pick back up with wide QRSs.